Welcome to my video lecture. This is Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today we are going to deal the subject Matrices and Calculus, one of the topic, rank of a matrix. So this subject now as per the new regulation, R25 regulation, we are following. In this we have the first semester, first year subject, Matrices and Calculus, subject code A7BS01, A7BS01. It has a credits, 4 credits, 1 3 theory and 1 tutorial hour. Total 4 credits are there. It is one of the important subject and very useful subject to the computer science student as well as the other branches people. One of the main aim of this subject to introduce the linear algebra concepts and matrices introduction to the student application. In this lecture, I am going to present matrices and calculus course. Under this course, what we are going to study, and especially in the unit 1, rank of a matrix, methods to find rank of a matrix, properties of rank of a matrix we are going to discuss. Right. So let me introduce the subject maths and calculus. So BTech first year and this is the first sem course, and it is common for all the branches, and R25 regulation we are following this one. The objective of this course is applying basic operations on matrices and their properties. Basically what type of matrices we have, where we can apply, this all we discuss, and the concepts of rank of the matrix and applying this concept to know the consistency and solving the system of linear equation. Especially the main application of matrices is solving the system of equation, especially linear system of equations, first degree equations. Third one, concept of eigenvalues and eigenvectors to reduce the quadratic form to canonical form. Using homogeneous concept, we can find for any square matrix eigenvalues and eigenvectors. With the help of the eigenvalues and eigenvectors, we can reduce the given matrix to quadratic form, and we can reduce the quadratic form to canonical form and diagonal form. So that are the use of eigenvalues and eigenvectors, and some more applications also we discuss. Cayley-Hamilton theorem, geometrical approach to the mean value theorems and their applications to the mathematical problems. Finding maxima and minima of functions of 2 or 3 variables. In intermediate level, used to study only one variable, f of x is equal to 0. Here, 2 variable functions, maxima and minima we determine. F of x comma y is equal to 0 or f of x comma y comma z is equal to 0 with some conditions. This is application of the differential equations, differentiation, maxima and minima, partial differentiation, evaluation of multiple integrals and their application, multiple, more than one integral, double integral and triple integrals, and especially their applications, area, volumes, change of order of integration, all these we discuss under this course. And as after learning the content of this paper, the student able to understand what he can get. So far what we have discussed, that he will achieve. Write the matrix representation of the set of linear equations and analyze the solution of the system of equations. Which type of solution it consists, system of equation, no solution or unique solution or infinite number of solution, and what type of solution can it have. It is application of the rank of the matrix, and as we discussed, that is a student able to find eigenvalues and eigenvectors, solve the applications of the mean value theorems, Rolle's, Cauchy's, Lagrange's mean value theorem and their applications we can learn, and verification of the mean value theorems. Find the extreme values, means maximum value or minimum values of 2 variables with or without constraints. The conditions are given, how to find maxima minima. Conditions are not given, 2 variable function, how to find maxima minima. That are called extreme values, either maximum value or minimum value. And the last one, evaluate the multiple integrals, double integrals and triple integrals. Apply the concept to find the areas and values. These are the outcomes of this course. So total 4 credits. If a student clear this subject, he will be getting 4 credits into his certificate. That's why it is one of the important subject and useful to the engineering students. So let briefly discuss what are the syllabus, what are the units we have under this syllabus. Unit 1, matrices. Just now we have discussed that one. Rank of a matrix, especially echelon form, normal form, inverse of non-singular matrices by Gauss-Jordan method, system of linear equations, solving system of homogeneous and non-homogeneous equations, Gauss-Seidel iteration method. Next, Unit 2, eigenvalues and eigenvectors, especially Cayley-Hamilton theorem, quadratic forms, these type of topics we have. Unit 3, single variable calculus, only one variable, f of x. In that one, here we have, especially this time, this topic was introduced newly compared to the R22 syllabus, especially mean value theorems. Again, the previous mean value theorems are introduced here. Rolle's theorem, Lagrange's theorem, geometrical interpretation, Cauchy's mean value theorem, Taylor's series expansion, these all are included in the single variable. And fourth unit, multivariable calculus, and more than one variable, 2 or 3 variables, especially definition of limit, continuity of multivariables. Next, applications, especially Jacobian, functional dependent, independence, maximum minimum of 2 variable functions, that all will be discussed here. Multivariable integrals, that is multiple integrals, double integration and triple integration, Cartesian form, and change of variables at a Cartesian to polar, one variable system to another system to evaluate the double and triple integrals. And applications, areas by double integrals and volumes by triple integrals. These are the 5 units we have, 2.5 unit and 2.5 unit for one mid examination, each mid examination. At the end of the 5 units, student will be having the external examination. Next, especially then what type of textbooks should be referred. The students generally will be having big doubt when they enter into the first year, first semester, as they come from the intermediate level. So here the main book for this one is Gravel, B.S. Gravel, Higher Engineering Mathematics. It is a well-known publishers and clearly explains the applications and all these things, and Khanna publications. The book consists the big volume book, and it consists the all the mathematics of the engineering. It can be the first year, first semester, second semester, second year, first semester, even for computer science students, ECE students, mechanical, aero, triple E, for all the students, required syllabus will be given. That is the whole engineering mathematics. In that one, our subject matrices and calculus are one part of the subject. So where you can find directly matrices topics and mean value theorem topics, and other 2 units, multiple integrals and multiple integration topics you can find. And one more book is given is R.K. Jain and Iyengar, Advanced Engineering Mathematics, Narosa publications, and some reference books. These are the standard textbook. These 2 we have given, and other than these 2, we can have the textbooks. That is a foreign author book, Erwin Krejcik, Advanced Engineering Mathematics. Next, G.B. Thomas, R.L. Finney, Calculus and Analytic Geometry. Here also you can find 3-4 units in this one. And Bali and Goyal, a textbook of engineering mathematics. H.K. Das and Rajesh Verma, Higher Engineering Mathematics. This is also S. Chand Company Limited, and S. Chand books also available. And these all books are useful for the matrices and calculus. Or in our library also we have n number of books where you can refer the books which contains our syllabus particular topic. So student has to refer topic wise. So in one book you cannot find all the units one by one, unit 1, unit 2, unit 3, you can't find. The student has to habituate for the library books, so he has to borrow the books, and in that one particularly Gravel book or Jain book, and topic wise they have to prepare the notes, or they can take the help of the faculty notes, right? This is the textbooks. Next, so here in this lecture I will start with the unit 1, matrices. Already we discussed here, especially first topic, our topic is rank of a matrix. Here we are finding using echelon form and normal form. Next, how to find inverse of non-singular matrices by Gauss-Jordan method. Intermediate level used to take using the concept A inverse is equal to adjoint of A by det A concept used to do. So here every time det A finding is not so easy, and adjoint of A also difficult. That's why here we use row operations method to find the inverse of the non-singular matrices. Next, system of linear equations. 2 by 2 equations, 2 unknowns, 3 equations, 3 unknowns, 4 equations, 4 unknowns, or like this system of equations will be given, that we are going to solve using the rank concept. Next, solving system of homogeneous and non-homogeneous. Under this system of linear equations. We are solving two types of equations, homogeneous and non-homogeneous equations. And one more method we have at the last of this unit, Gauss-Seidel iteration method. It is not the rank method, it is a numerical method actually, but it was given in the matrices concept. But we don't use the matrix concept here. We use numerical iteration method we use, that is called Gauss-Seidel method, that also we discuss. Next, first topic we are going to that is rank of a matrix. Actually, what do you mean by rank? It is actually a property, a unique property, as a characteristic of a matrix. Suppose one matrix is given, for the matrix it is one of the property which is unique. It will help us in finding the system of equation solution. So here, to precisely to say the rank of a matrix, generally the number of linearly independent rows or columns of the matrix. Suppose a matrix has 4 rows, 3 rows or 5 rows. In that one, how many are linearly independent? At one row will not depend on another row. So no relation, dependent. So dependent means one row and another row has a relation. Suppose R2 is equal to there is 2 into R1. Then R2 and R1 are both are dependent, not linearly independent. Suppose let us say 1, 1, 1, 2, 2, 2, 3, 3, 3. Look at this 3 rows. These three rows are linearly dependent, not independent. See, first row R1, using R1 I can find R2, I can find R3. So R2 is equal to 2 into R1, R3 is equal to 3 into R1. These three are dependent. But how many linearly independent rows in this matrix? Only one row, any one of the row. So then precisely we can say rank of the matrix is only 1. Because even we have the 3 rows, linear, how many are linearly independent rows means here that is 1. Here 1, 1, 1, 2, 2, 2, 3, 3, 3, student easily can identify, but every time the matrix cannot be given in this form. At the time, then how we find, then we use some particular methodology or methods to find the rank of a matrix. So briefly you want to say what is the rank of the matrix means number of linearly independent rows, or it may be columns. That is that one. So mathematically here we are maximum number of linearly independent rows. Mathematically you want to say 2 3 4 it is a number, right? It will be unique, it cannot be different for a matrix. So what method you applied, whoever you find, it will be unique. Suppose this I have taken the matrix A, here 3 rows are there but only one independent row, the rank is 1. It is unique. So our maximum number of linearly independent rows or maximum number of linearly independent columns, anything is same, both are same, and we can say this is the rank of the matrix, right? Next, so see here already I have given one example, one more example. Look at this matrix here, first row 1 2 3, second row 2 4 6 and third row 3 6 9. Look at this one, if you observe very carefully, here R2 elements are 2 times of R1, right? 2 into 1 2, 2 into 2 4, 2 into 3 6. R2 clearly obtained from R1. Similarly R3 is also, that is 3 R1. See, multiply the first row, 3 into 1 3, 3 into 2 6, 3 into 3 9. Here even the 3 rows are there, the 3 in the 3 are linearly not independent. Only one row is linearly independent. So clearly here one row, which row or first row. So using the first row, easily we can make these 2 rows zeros. So generally by row operations we can get this 5. So again we discuss what are the row operations, that all we discuss. To make you understand, I am telling even 3 rows are there, only one row is linearly independent. Other 2 rows are depending on the one row, R1. So how many linearly independent rows are there means only one row, therefore rank of the matrix is 1. Very clear. So that is the rank concept. But again, every time the matrix cannot be simple to identify like this. Every time the row, one row is cannot be a multiple of another row. We cannot say. At the time we need a particular methodology, right? Now first we discuss the definition, rank definition. It was frequently asked in the examination point of view, and the student must be able to write this definition properly. Once the definition is properly understood, easily we can solve the problems. Now for a non-zero matrix, R, a number R, particularly a number R is said to be rank of the matrix if 2 conditions are satisfied. What are the two conditions. A number R, some 3, some 4, some 5, you are telling as the rank of the matrix. Then all the R plus 1th order minors must be 0. Then what do you mean by the minor? Right? Minor, for a given matrix, what is the minor? Minor is the det of square submatrix which is obtained from the matrix. Let us have 2, 3, 4, 1, 5, 0. So in this one I am taking one submatrix 2, 3, 1, 5. So minor, determinant of the square submatrix. So one submatrix if I take, that is 2, 3, 1, 5. This is a submatrix which is obtained from a given matrix, let us say A. If you find det of this matrix, that will be the minor. So let us say this one, 5 into 2, 10, 10 minus 3, 7, right? So 5 into 2, 10 here, and minus 3, which is equal to 7. It is a minor. So what is the here meaning? Minor means determinant of the square submatrix. Now if you want to tell R is the rank of the matrix, then R plus 1th order minor must be 0 if they exist. Depends on the order of the matrix. Suppose it is a 3 by 3 matrix, rank is 3. Then 3 plus 1 4th order minor does not exist. If exist, that must be 0. At a minor of R plus 1 must be 0. Whenever you are claiming R is a rank, there exists at least one minor of the R which is non-zero. You must be able to find at least one, not all the minors, at least one minor of order R which is not equal to 0, which is non-zero. You are telling rank 3, suppose example, then there exists a 3 by 3 minor which is not equal to 0, and all the minors of order 3 plus 1, suppose 4 by 4 minor is there, that must be 0. Suppose we have minor of 5 by 5, that also must be 0, right? And you are telling, suppose rank of A is 3, let us say, then 3 by 3 minor must be at least one minor. In the matrix, how many are present? That depends on the matrix, but at least one minor which is non-zero. Then only you can declare that number R as a matrix, and R plus 1 order must be 0. Right? Clear? So R plus 1 minus 0 and det of R not equal to 0. So simply the rank of the matrix, in our words, suppose you are unable to tell like these two equation sentences, you can say the rank of the matrix is the order of the highest order minor which is non-zero. In the given matrix, what could be highest order minor which is non-zero? Maybe 2 by 2 minor not equal to 0, maybe 3 by 3 is not equal to 0, maybe 4 by 4 is not equal to 0 in the given matrix. What is the highest order? Suppose 4 by 4 is the highest order minor which is not equal to 0, then 4 will be taken. Okay, even 3 by 3 minor not equal to 0, even 2 by 2 minor not equal to 0. Highest order minor will be taken as the rank of the matrix. So precisely you can say the rank of the matrix is the order of the highest order minor which is non-zero. We discussed with some examples also, right? So here, what are the actual methods given in the syllabus to find the rank of the matrix? Here we have one is echelon form, another one is normal form. Both methods we'll discuss in the coming video lectures. First we rank properties, that all we discuss, then we discuss echelon form and normal form to find the rank of the matrix. See, properties of rank of a matrix. So rank of a null matrix is 0. What do you mean by null matrix? All the entries are 0 in the matrix. Let us take the example. Suppose a matrix containing 0, 0, 0, 0, 0, 0, 0, 0, 0. So it is a null matrix. Definitely the rank of the matrix. So rank of the matrix is denoted by row. This is a matrix, row of A. This is 0. Rank of a matrix is denoted by row R of A, row of A, we can write. So for any null matrix, all entries are 0. It is a 2 by 2, 3 by 3, 10 by 10 null matrix also, rank will be 0. Rank of null matrix is 0. Next, rank of identity matrix is order of the identity matrix. So this is a rank of identity matrix. Everybody knows identity matrix. What do you mean by identity matrix? Suppose I2 1 0 0 1. Then there are 2 will be rank. Rank of this matrix is 2. Suppose I3. I3 means diagonal elements 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. So for this one, rank of the matrix, rank of the I3 is 3. Okay. So order of the identity matrix is IN, N, I4, rank 4, I5, rank 5. So rank of the identity matrix is the order. 2 by 2, 2, 3 by 3 means 3. So identity matrix, everybody knows the principal diagonal elements are unity 1, remaining elements are 0. Such type of all the matrices you no need to find. Directly its order will give the rank. For null matrix also we no need to find, just directly 0 is the rank. Then rank is less than or equal to the minimum number of rows and columns. Suppose a matrix is given 3 by 4. So in the 3 and 4, what is the minimum number? 3. So for this matrix, rank of A will be less than or equal to minimum of 3 and 4 is 3. That is the statement here. Rank is less than or equal to minimum of number of rows and number of columns, whatever it may be. Suppose it was given like that. A is equal to matrix is given, that is 5 cross 4. So then here matrix rank will be less than or equal to minimum of 5 and 4. Minimum of 4, 5 and 4 is 4. That does not matter rows or column. Minimum of rows and columns number it will be. Matter maximum rank how much you can get is a 4 only here. In the 3 by 4 it is 3 only. 4 by 4 4. 4 by 5 4. 6 by 3 3. Minimum number. The rank cannot exceed the minimum number of the row and column. That is less than or equal. Every matrix will have a rank. Whatever the matrix you take, you give one matrix, definitely it will be having some rank. Depends on the matrix. And null matrix 0, other matrix is 1, 2, 3. Okay, next. Rank of a matrix is unique, that is 1 and only 1. Rank of A is greater or equal to 1 when A is a non-zero matrix. Right? For every non-zero matrix, minimum rank will be 1. So these are the properties. Next, so we have great applications of the rank of the matrix, that is solving system of linear equations, which type of solution is existing, and in engineering physics also we have this application, that is in the structural engineering. Rank determines whether the structure is a stable or unstable. Control system, rank is used to check whether the controllability of the observability of a system. Signal processing. In computer science also we have the great applications. In search engines, especially search engine, when we are doing the Google search, how a page is uploaded, which one is coming first, these all using Google page rank. We have the rank application. Singular value decomposition, image compression, image enlarging and synchronizing, that is all used here in the computer science, and many other applications we have, right? So find the value of K such that the rank of the matrix is 2. So here saying rank 2. Rank 2 means definitely the rank of the matrix, suppose he has given is 2. Then det of the matrix. So minor of 3 by 3 and R plus 1. So as we discussed the rank definition, suppose rank is equal to, then 2 plus 1. The 3 by 3. Det must be 0. Since he has mentioned rank is 2. So then we can solve here by directing the determinant equal to 0, 1, 2, 3, 2, K, 7, 3, 6, 10. So equal to what's a 0. Since rank is 2, 3 by 3 minor must be 0. Solving easily we can get K value. So everybody knows how to find the determinant, right? 1 into 10 into K, 10K, minus 7 into 6, 42. Next minus 2 into 10, 20, minus 7 into 3, 21. Next plus 3 into 2 into 6, 12, minus 3K is equal to 0. So most of the students, what the mistake they will do here, that is equate to 2. So equate to 2 is kind of wrong. So determinant should be equated to 0, because rank 2, 3 by 3 must be 0. So simplifying we can get, so 10K minus 42. So 20 minus 21 minus 1, that is a plus 2. 3 into 12, 36, minus 3 into 3K, 9K, right? 9K, which is equal to 0. So 10k minus 9k, k, right? 10k minus 9k is a k, minus 42 plus 40, minus 40 plus 36 minus 4. So k is equal to 4. So like this, we can find some unknowns when the matrix as given and some rank is mentioned. Here the concept is rank 2 at a 2 plus 1 minor must be 0, that is 3 by 3 minor. Take that of the given matrix must be 0. We got the k value, right? And at the end of this session, right, we have discussed about what is the matrices calculus course introduction, what are the units we have, what are the textbooks, and what is the rank of a matrix, and properties of rank of the matrix, and methods to find the rank of a matrix, echelon form and normal form. Again, we discuss very clearly in the coming classes. In the next classes, we discuss about echelon form and normal form to find the rank of a matrix. So, thank you.